Welcome to another video lecture. In this video lecture, we will discuss a few special cases in Routh-Hurwitz criteria. In the first case, we will discuss if any element in the first column of Routh table becomes 0, then how to proceed these type of numerical problems and how to predict whether the system is stable or not. So in this example number 3, we are given with f of s is equals to s to power 5 plus s 2s power 4 plus 3s cube plus 6s square plus 2s plus 1. Now first we will create the Routh table. Now you might remember the formula to create the Routh table. Let me write it here. So if f of s is given in this equation, f of s is equals to, this is a standard equation of the characteristic equation, then how to create the Routh table? We will start with the highest power of s, which is s to power n, then the decreasing s to power n minus 1, s to power n minus 2, and so on. And then we will write the elements coefficients. This we already discussed in the previous classes. So let us now create the Routh table for this particular example. So we will make a Routh table, and we will start with the highest power of s, which is s to power 5, and then we will write s to power 4, s to power 3, s square, s to power 1, and s to power 0. And then we will write the coefficient in the first row, which is s to power 5. So we will start with the coefficient of s to power 5, which is 1. So we will write here 1. Then the next coefficient will be the alternate s to power, which is the coefficient 3, and then the alternate coefficient is 2. So we will write 2 here. And then for the second row, s to power 4, the first coefficient will be 2, which is the coefficient of s to power 4. The next coefficient is the alternate of s to power 4, which is 6, and the next is alternate, which is 1. So this is how we will write the first 2 rows of the Routh table from the coefficients of the given characteristic equation. Now the first element of this row, s to power 3, will be determined by using this b1, which is given by this expression here, where a1, a2, and a0, a3, a1 are the elements of the first 2 rows of the Routh table. So I'm directly writing here because we have already covered these formulas and few examples in the previous classes. So I'm directly writing the first coefficient, which will be let me write the calculation here. This will be 2 into 3 minus 6 into 1 divided by 2. So let me write it here, 2 into 3 minus 6 into 1 divided by 2. So this will comes out to be 6 minus 6 divided by 2 will comes out to be 0. So the first element of this row s to power 3 will be 0. Now the second coefficient will be this 2 into 2 minus 1 into 1 divided by 2. Let me write it here, 2 into 2 minus 1 into 1 divided by 2. So this will be 4 minus 1 divided by 2. So this will be 3 by 2. Now the remaining coefficient will be 0 because there is 0 and 0. The next elements are 0, so the remaining coefficient will be 0. Now when you will calculate the first element of this row s to power 2, this element, because this will be divided by this first element 0, the remaining coefficients will comes out to be infinity. Let me write this coefficient. Let me give the calculation. This will be 0 into 6 minus 3 by 2 into 2 divided by 0. Let me write it here. So this will be 6 into 0 minus 3 by 2 into 2 divided by 0. So this will comes out to be infinity. So the problem with this, when any element of the first column of Routh table becomes 0, it will make the remaining elements of the first column to be infinite, and in that case we cannot predict whether the system is stable or not. So in this case, what we will do, we will first substitute a small positive number epsilon. We will first substitute a small positive number epsilon in place of 0. So instead of this 0, we will replace this 0 with the small positive integer epsilon, and then we will complete this Routh table. We will complete this Routh table, and in the end we will examine the sign change of the first column by taking this epsilon limit, epsilon tends to 0. So if there is a sign change in the first column after taking this limit epsilon tends to 0, then we will say that this system is unstable. If there is no sign change in the first column, then we will say that the system is stable. So let us first take this epsilon instead of this 0, and then we will complete the table. Let us take this value equals to epsilon here. Now the first element of S square will be this epsilon will be multiplied by 6, then this 3 by 2 multiplied by 2 and divided by epsilon. Let me write this here. So this will be 6 into epsilon minus 3 by 2 into 2 divided by epsilon. So this value comes out to be 6 epsilon minus 3 divided by epsilon. So the first element here 6 epsilon minus 3 divided by epsilon. And the second element of this row S square will be epsilon multiplied by 1 minus 0 multiplied by 2 divided by epsilon. Let me write it here. So this will be epsilon into 1 minus 2 into 0 divided by epsilon. So this value comes out to be 1. So this value will be 1. The remaining will be the remaining elements will be 0, 0, so on. Now the first element of S to power 1 will be this quantity multiplied by 3 by 2, epsilon multiplied by 1 divided by this. So let me write it here. So 6 epsilon minus 3 divided by epsilon into 3 by 2 minus epsilon divided by 6 epsilon minus 3 divided by epsilon. So let me further simplify this. So this will comes out to be 6 epsilon. So let it put it as it is. Then we will in the end we will take the limit epsilon tends to 0. So let us put this as it is. Into 3 by 2 minus epsilon divided by 6 epsilon minus 3 divided by epsilon, and the remaining elements will comes out to be 0, 0, since the rest of the terms are 0, and the coefficient of s to power 0 we know that this comes out to be the constant value 1. So this will be 1. Now let us examine the sign change in the first column of this Routh table. So this is the first column of this Routh table. Now we will examine the sign change by taking epsilon tends to 0. So this first term s to power 3 coefficient epsilon, so we are taking this epsilon tends to 0. So let us assume that this will be 0 here. So this epsilon tends to 0. So this will comes out to be 0. Now the second s square, let us examine the sign change in the s square term. The first element is 6 epsilon minus 3 divided by epsilon. Let us examine the sign change. I am writing it here. Limit epsilon tends to 0, 6 epsilon minus 3 divided by epsilon. I can also write it as limit epsilon tends to 0, 6 minus 3 by epsilon. When I will put this epsilon tends to 0, this will comes out to be minus infinity. So this s square, the first element of this s square row will comes out to be tend to minus infinity when epsilon tends to 0. Now the first element of this s to power 1. So let us examine the sign change of the first element of s to power 1. 6 epsilon minus 3 divided by epsilon into 3 by 2 minus epsilon divided by 6 epsilon minus 3 divided by epsilon. So when you will put epsilon tends to 0 in this equation, this will comes out to be 3 by 2. I think it is 1.5. So this will comes out to be 1.5. This is minus infinity. This is 0. This is 2. This is 1. So there is one sign. There is two sign change actually. When you go from this s to power 3 to s to power 2, there is a sign change from 0 to minus infinity. Then you again go from s square to s to power 1. There is again a sign change from minus infinity to 1.5. So there are two sign changes. Let me write it here. There are two sign changes. Hence, the system is unstable. So this is how we will solve any Routh-Hurwitz criteria problem in which any element of first column of Routh table becomes 0. We will assume that to be equal to a small positive integer epsilon, and then we will complete the Routh table, and in the end we will examine the sign change by taking limit epsilon tends to 0. If there is a sign change, then we will say that the system is unstable. If there is no sign change, then we will say the system is stable.